Hi everyone, this is Lisa. I'm going to try and go over Rossi's Chapter 10, Magnitude of a Program Effect, as best as I can. I definitely am no statistics teacher, but I'll give it a whirl. So, what is a magnitude of a program effect? What does this mean? It's basically an impact assessment. That is used to detect and describe program effects and depends on the magnitude of the effect that the program produces. It is also used in understanding the issues involved in detecting and describing program effects and requires that we must first consider the magnitude of a program effect. So we're trying to figure out if a program was effective or not in simplest terms. Basically, what researchers call a program effect, basically it's just the difference between the outcome measured on the program's targets receiving the intervention and an estimate of what the outcome for those targets would have been had they had not received the intervention. So we're doing a little comparison. What was the outcome of those that received an intervention versus not received? A very simple comparison analysis. Therefore, the most direct way to characterize the magnitude of a program effect is to take the difference between the two means of the two outcome values. For example, this was one right from Rossi Chapter 10. The mean score in a multi-item outcome measure of knowledge about hypertension was 34.5 for those exposed to a hypertension awareness and informational campaign, compared to the 27.2 of those in the control group that were not introduced to the campaign or subject matter. So if we were to subtract the 34.5 of those who actually learned something from the campaign and the 27.2 that were in the control group, we get a difference of 7.3, and this would be the program effect. The program effect value, So to continue, some people don't use a program effect value. They want to use a percentage to compare what was successful and what was not. So some people feel that it's usually more convenient and meaningful to represent the values of measurement in a form that is not so closely tied to a specific measurement procedure. One could talk about the rate increase in percentages like so. So what you do is you take the difference, 0.17 minus 0.12, and you get 0.05, right? So that's the difference between the studied group and the control group. And then you divide it by the total in the control group. And this gives us a percentage of 41.7 increase in awareness about hypertension. Because these scales of measurement techniques change numerically, and they actually change the numerical outcomes, and there's way too many scales of measurement that researchers are using and people would use, even administrators would use, to evaluate a program. Evaluators often use an effect size statistic to characterize the magnitude of a program's effect rather than taking a raw difference score or a simple percentage of change. So in order to be more consistent, we do an effect size statistic. So what does an effect size statistic do? An effect size statistic expresses the magnitude of a program effect in a standardized form that makes it comparable across measures that use different units or scales. So here we are unifying how we're going to express a program effect. Did this program work or did it not work? The most common type of effect size statistic is the standardized mean difference. So this is the tool, the most standardized tool, the standardized mean difference. What is the standardized mean difference? It is basically a value that expresses the mean outcome difference between an intervention group and a control group in standard deviation units. And standard deviation units provide information about the range or spread of scores. Using these units indicates how large the effect is relative to the range of scores found between the lowest and highest ones recorded in a study. You can then compare standardized mean difference in order to compare programs to see which program is more effective. So, to summarize, we're using standard deviation units, and we're doing this in order to provide consistency, and we're basically taking the lowest and the highest recorded in a study, and then we're then we can compare a standardized mean difference in order to compare whether programs are, which one's more effective. Some outcomes are binary rather than a matter of degree. So an example of binary outcomes include committing a delinquent act, becoming pregnant, or graduating from high school. All these acts are unpredictable. So for binary outcomes, an odds ratio effect size is used to characterize the magnitude of a program effect. An odds ratio indicates how much smaller or larger the odds of an outcome effect is. For example, when you want to predict, can you predict somebody? You can't predict somebody becoming pregnant, right? So we're talking about something kind of difficult to make a measurement on, right? So when an odds ratio is greater than 1, it means that the participants in the intervention group are no more, no less likely than the control group to experience a change in question based on a program. For example, if the odds ratio is 2, then members of the intervention group are 2 times more likely to experience the outcome than members of the control group. Odds smaller than 1 mean that they were less likely to experience any outcome at all. So just to review, the standardized mean difference effect size statistic is especially appropriate for representing intervention effects found on continuous outcome measures. When the standardized mean difference effect size comes out positive, then the outcome is more favorable for the intervention group. If negative, then it is more favorable for the control group. The odds ratio effect size statistic is designed to represent intervention effects found on binary outcome measures, that is, measures with only 2 values, such as dead versus alive, success versus failure, and so on. The outcome values achieved in an impact assessment always include a certain amount of statistical noise stemming from measurement error. If a difference in measured values comes only from statistical noise, then one is more likely to mistake that difference for an actual program effect. We need to know if an apparent effect is actually statistical noise, and we figure it out by using a statistical significance test. Yes, we're adding more to the vocabulary words here. So, what is a signal? If a signal or the estimate of a program effect that we observe from the data is large relative to the expected level of statistic noise, then one will be relatively confident that they have detected a real effect and not a chance pattern of noise due to error. If the program effect estimate is small relative to the pseudo effects likely resulting from statistical noise and all the things that go into make experimental error, then one would have little confidence that they observed a real program effect. So maybe the program is definitely not working. The statistical significance test is an evaluator's first assessment of the magnitude of a measured program effect in an impact assessment. When program effects are not statistically significant, this result is generally taken as an indication that the program failed to produce any effect at all. Impact assessment research designs yield conclusions about the statistical significance of program effects and allow the extraction of statistical effect sizes. And lastly, let's talk about meta-analysis, this whole process of analyzing. Did the program work? Did the program not work? What was the value for the control group versus what was the value for the intervention group? So lastly, the result of meta-analysis can be informative for evaluators designing impact assessments. Their findings typically indicate the outcomes affected by the type of program represented and the magnitude and range of effects that might be expected on those outcomes. They also provide a basis for appraising the effects found in an impact assessment in comparison to those found in similar programs. So I know this presentation was not perfect, but I would like to tell you this. This is my understanding in a nutshell. When we are analyzing whether a program is effective or not, any program at all, we have to have a consistent unit of measurement. We also have to make sure that we are not saying that an evaluation, or excuse me, after an evaluation that a program has worked based on a good numerical value, because we could definitely have some of this measurement or this noise. We could take into account numerical data that was not correct. And so we can't be too quick to jump and say, oh, our program worked based on this statistical number and this statistical evaluation. We have to continually evaluate the data to make sure that we are not jumping too quickly into saying that a program is highly effective or not effective at all. That's my very quick summary. Thank you so much for listening to me talk about ROSI Chapter 10, and have a good night.